in the sum, PQ is given 1.28 and PR is given 2.56. PE is 0.18 and PF is 0.36. So first we have to find PQ and FR. So what we will do? PQ is equal to PE plus EQ. Okay, why this? P dash E dash Q. You can write that reason. Now PQ is given 1.28, PE is given 0.18. We have to find EQ. So EQ will be what? 1.28 minus 0.18. So EQ will be, I'm doing a rough work here, 1.28 minus 0.18. So 8 में से 8, 0, 2 में से 1, 1, 1. So what I get? 1.1. So I'm marking it as 1. Second, I have to find PR is equal to PF plus FR. Okay, again P dash F dash R. So PR they have given us 2.56, PF is 0.36 plus FR. So FR will be 2.56 minus 0.36. So FR will be, again I'm doing a side work, 2.56 minus 0.36, 0, 5 में से 3 गया 2, so I got 2.2. I'm marking this as 2. Now we'll go back to BPT, that is PE upon EQ is equals to PF upon, अच्छा पहले PE निकालते हैं. PE कितना है? 0.18 and EQ we found 1.1. So again I have to get rid of the point, so I get 18 divided by 100 and 11 into 10. So 0, 0 gets cancelled. Now this is and odd numbers. So I'll just mark it as 1. Let's see what we get for the second equation. PF upon FR, which is equals to PF is 0.36 and FR we got 2.2. So again I'll get 36 into 100 and 22 into 10. So I can cancel 2 ones are 2 ones are 2 ones are 2 8s are. So here also I got 18 upon 11. So I marked this as 4. So here you can write you have taken it from 1 and here you can write the value you have taken it from 2. So from 3 and 4, again you can see both the values are same. Therefore, PE upon EQ is equals to PF upon FR. So, by converse of BPT, EF is parallel to QR. Okay, coming to question number 3. It says in the figure, LM is parallel to CB and LN is parallel to CD. We have to prove AM upon AN is equal to, AM upon MB is equal to AN upon ND. So let's start with the proof. Okay, first I'm taking this triangle ACB. ACB. Can you see this triangle? So, in triangle ACB, LM is parallel to BC. Therefore, by basic proportionality theorem, what do I get? AM upon MB is equals to AL upon LC, and I'm going to mark this as 1. Similarly, we are going to do in triangle AC. Can you see this triangle? Again, LN is parallel to CD. Therefore, by basic proportionality theorem, I'll get AN upon ND is equals to AL upon LC, and I'm marking this as 2. So if you look at 1 and 2, the left hand side is same, therefore the right hand side will be same. So I write from 1 and 2 the right hand side, that is AM upon MB is equals to AN upon ND. Now after this, what I am going to do is I am going to do inverse. The denominator will go to the numerator and the numerator will come to the denominator. Okay, so I can say by invertendo, I'll get MB upon AM is equals to ND upon AN. Now I'm going to add 1 to both sides. What do I get? MB upon AM plus 1, ND upon AN plus 1. So if I go back to the figure and see, MB plus AM becomes AB. So MB plus AM upon AM or ND plus AN upon AN. So this becomes AB upon AM and this becomes AD upon AN. Again taking reciprocal or by invertendo, what do I get? AM upon AB is equals to AN upon AD. Hence proved. Okay, the fourth sum in this figure, it says DE is parallel to AC and DF is parallel to AE. Okay, so we have to prove BF upon EF is equals to BE upon EC. So let's start with the proof. Okay, I'm going to take triangle ABC, the entire triangle. Okay, so in triangle ABC, the first thing I'm taking, that is DE is parallel to AC. So if DE is parallel to AC, by basic proportionality theorem, what will I get? So I'll get BD upon AD is equals to BE upon EC. I'm marking it as 1. Now I'm going to take triangle BAE. Now in triangle BAE, again the second part, that is DF is parallel to AE. So therefore, by basic proportionality theorem, what do I get? I get BD upon AD is equals to BF upon FE. I'm marking it as 2. Now if I look at 1 and 2, my left hand side is same. BD upon AD, BD upon AD. So from 1 and 2, my right hand side will also be same. That is BE upon EC is equals to BF upon FE. Hence proved. Okay, starting with question number 5. What is given to us? DE is parallel to OQ and DF is parallel to OR. We have to show that EF is parallel to QR. Fine. So I am starting with the proof. First I am going to take triangle. Okay, first I am going to take triangle POQ. So in triangle POQ, yes, they have said DE is parallel to OQ. So DE is parallel to OQ. So therefore, by basic proportionality theorem, what do I get? PD upon DO is equals to PE upon EQ. I'm going to mark this as 1. Now I'm taking triangle POR. So in triangle POR, again DF is parallel to OR. So what do I get? By basic proportionality theorem, yes, PD upon DO is equals to PF upon FR. Okay, so I'm going to mark this as 2. Now look at 1 and 2. My left hand sides are equal. Yes or no? So therefore my right hand side will also be equal. So what do I get? I get PE upon EQ is equals to PF upon FR. So marking this as 3. Now if you go back to the figure and see PE upon EQ is equals to PF upon FR, this means EF is parallel to QR. So finally what I'll take? In triangle PQR, PE upon EQ is equals to PF upon FR from 3. Therefore, EF will be parallel to QR by converse of BPT. Question number 6, it says in the figure A, B and C are points on PD, PQ and OR. Fine, respectively such that AB is parallel to PQ and BC is parallel to PR. We have to show BC is parallel to QR. So I'm starting with the proof. First I'm going to take in triangle OPQ. Can you see this triangle? So in triangle OPQ, we have AB is parallel to PQ. So first thing is given, we are going to take that only. So again, by basic proportionality theorem, what will I get? Below, OA upon AP is equals to OB upon BQ. I'm going to mark this sec 1. Now I'm going to take triangle OPR, the second one, AC parallel to PR. Yes, so AC is parallel to PR. This is again given to us. Therefore, what we can say by BPT? By BPT, we can say OA upon AP is equals to OC upon CR. I'm going to mark this as 2. Again, compare 1 and 2. I can see my left hand side is equal. Therefore, my right hand side will also be equal. So, what will I write? From 1 and 2, OB upon BQ is equals to OC upon CR. So, if you go back to the diagram and see, OB upon BQ is equal to OC upon CR. So, from the diagram, we can say BC is parallel to QR by converse of PT. Okay, starting with the 7th sum, it says using theorem 6.1, prove that a line drawn through the midpoint of one side of a triangle is parallel to another side and bisects the third side. So D is midpoint, this is given to us of AB. We have to prove that E is also the midpoint. So let's start with the proof. Now I am taking in triangle ABC. D is midpoint of AB. This is given to me, right? So can I say AD upon DB is equals to 1. I'm marking it as 1. Now why it is both are equal to 1? Because of midpoint theorem. Midpoint theorem में हमने पढ़ा है. This is equal to this, right? So I can say line L is drawn through D such that L is parallel to BC and meets AC at point E. So now if I apply BPT, what will I get? AD upon DB is equals to AE upon EC. We have told that this is equal to 1. Therefore, the next right hand side, that is AE upon EC, will also be equal to 1. I am marking this 2. So, from 1 and 2, can I say AE is equal to EC? Yes. दोनों इक्वल होंगे तब जाके उनका रेशियो 1 होगा. That means E is midpoint. Understood? Of AC. Okay, starting with the 8th sum. Using theorem 6.2, prove that line joining the midpoints of any two sides of the triangle is parallel to the third side. So I have taken this triangle ABC, and D and E are the midpoints of AB and AC. So I have written D and E are the midpoints, and I have to prove DE is parallel to BC. So I'll start with the proof. So I know D and E are midpoints. So by midpoint theorem, can we say if D is the midpoint, AD upon DB is equals to 1, and if E is the midpoint, AE upon EC is equals to 1. I'm marking this as 1 and this as 2. So from 1 and 2, can I say both are equal? That is AD upon DB is equals to AE upon EC. And if these two are equals, by converse of BPT, yes, DE is parallel to BC. Hence proved. Okay, starting with the 9th sum. ABCD is the trapezium in which AB is parallel to CD. Okay, and diagonals AC and BC intersect each other at O. We have to show that AO upon BO is equals to CO upon D. I have done a bit of construction. I have made a line which is parallel to CD and AB, that is EF. So now I am going to take in triangle ACD. I think you can see this triangle. Now EO is parallel to CD. So now I am going to apply BPT. So what will I get? AE upon ED is equals to AO upon OC. I am marking it as 1. Okay, now can you see the green part? I am going to take this green part of the triangle, that is in triangle ABD. Now, again OE is parallel to AB now. So, OE is parallel to AB. Therefore, now apply BPT. What do I get? ED upon AE is equals to DO upon OB. I am going to mark this as 2. Now, if I take reciprocal of this, first I'll take reciprocal. Yeah, you can say invertendo, and then we'll mark 2. So, if I reciprocal, I get AE upon ED is equals to OB upon OD. Now, I will mark 2. Now, if I look 1 and 2, can I see the left hand sides are equal? Yes. So, from 1 and 2, what do I get? AO upon OC is equals to OB upon OD. Okay. Now, I am going to change these two. What do I get? AO upon OC is OB is equals to OC upon OD. Hence 2. Let's do the 10th sum. The diagonals of the quadrilateral ABC intersect each other at point O such that AO upon BO is equals to CO upon D. Show that ABCD is trapezium. So last sum में जो हमने prove किया था, इस sum में हमको वो दिया है, and we have to prove ABCD is trapezium. That means this sum is converse of last sum. So I have done a bit construction. I have drawn OE. Okay. So I'm starting with the proof. What is given to us? AO upon BO is equals to OC upon OD. So if I look in the figure, AO upon OC is equals to BO upon OD. Okay, so these are the diagonals. I'm marking this as 1. Now I'm taking triangle ADB or DAB. I've done this construction, that is OE is parallel to AB. Therefore, what will I get by BPT? Yes, DE upon AE is equals to DO upon OB. I'm marking this as 2. No, first I'll take reciprocal, then I'll mark. So after taking reciprocal or after taking the invertendo, what do I get? I get AE upon DE is equals to OB upon OD. Now I will mark it as 2. So ये जो 1 था इसको मैंने BO को CO में कन्वर्ट किया है और उसको 2 मार्क किया है और अभी जो हमको मिला है उसको मैंने 3 मार्क किया. So if I compare 2 and 3, so I can see BO upon OD and BO upon OD. So I'll write here from 2 and 3. If my left hand side is equal, my right hand side will also be equal. That is AO upon OC will be equal to AE upon D. So if you go back to the figure, AO upon OC is equals to AE upon ED. What does this mean? This means OE is parallel to CD. Therefore, OE is parallel to CD. Now we have proved OE parallel to CD. Similarly, we can prove OE is parallel to AB. So if this is parallel to this and this is parallel to this, तो ये दोनों भी parallel हो जाएंगे. So that is what is the property of trapezium, that opposite sides are parallel. So if we prove then these are parallel, then we have done the sum. So therefore we can also, or similarly we can prove OE is parallel to AB. Therefore, if I mark this 4 and mark this 5, so from 4 and 5 I can see CD is parallel to AB. So if CD is parallel to AB, therefore we can say quadrilateral ABCD is the trapezium. So we are done with 6.2.